This is incredible. An Ontario County nonprofit. Overlook Horizon high-altitude balloons.
3, 2, 1.
Good morning, Space Lobster Nation. How we doing today? Tori here from Overlook Horizon. Today is not working with our music. Where's our music? Today is Thursday, July 30th. I have music. It's not there. I don't know where the music went. It was just playing a minute ago. There it goes. Wow. Hello. That was weird. Okay. Anyways, if you're watching the replay back, Thursday, July 30th, for our first launch attempt for the Mars 2020 mission here, sending the Mars Perseverance rover to the Red Planet this morning. Now that we got the music thing sorted out, I think we're ready to go. But good morning, everybody. It's 7:20 a.m. Eastern time here. Liftoff is scheduled for about 30 minutes from now. So we're coming up on launch, and everything so far this morning is looking fantastic. All my buttons. I changed a whole bunch of things around since our last live stream, and so all my buttons are in different places here. So here's the Atlas V, the Atlas V 541 rocket on the launch pad. That 541 meaning that is a 5 meter payload fairing, 4 solid rocket boosters, and 1 single Centaur upper stage engine powering that second stage there. This is hopefully going to be launching here shortly, and then it will take a 7-month trip to Mars. It's going to be a while to get there. I think it's just this track that's muted, because there we go. Let's just, because we lost our music again there. Okay. Distracted by the music. It's very loud in my ears, so it's very significant when it goes quiet. GVA Morning Show. Hey, good morning to you. Go Mars 2020. Yes, I'm excited for this. I'm really excited for this mission. There's a whole bunch of things about this rover. This is an SUV-sized rover, the largest rover that we've sent to Mars. It has a whole bunch of upgraded things on it and sensors for science and research and all kinds of things like that, which we'll get into here in just a couple of minutes to take a look at what all the sensors are on it. But I'm super excited for a couple of things, probably the 3 biggest things that I'm excited for. One, upgraded cameras. Super excited for upgraded cameras. Like, I just love seeing those actual pictures of Mars. So upgraded cameras is number 1. Number 2 is the MOXIE experiments, which is going to make oxygen on Mars. The idea is to pull oxygen from the environment to prepare for making fuels on board Mars. So if we're gonna send, say, like a sample return mission, or even humans to Mars for that matter, having the ability to do in situ resource utilization, meaning you're using the resources on Mars to actually make your liquid oxygen to send the rocket back, is going to be necessary. You don't want to have to bring all that liquid oxygen with you. That'd be super heavy. So if you can make it while you're there to send the rocket back, that'd be awesome. And this is the first time that we're sending a rover there to actually perform and kind of test that operation. So that's number 2. Number 3 is the Ingenuity helicopter. I'm really excited about the Ingenuity helicopter. So there's a helicopter on board, a dual center rotor helicopter, meaning they're stacked on top of each other. I got pictures that we can take a look at in a minute. But dual rotors, and this thing will be offloaded by the rover after it lands. The rover will drive away, and then the rover should actually watch the Ingenuity helicopter fly on Mars. Remember, Mars is only 1% of the atmosphere that we have here on Earth, so trying to fly a helicopter, which kind of needs some atmosphere, on Mars is really hard. That's why it has to, the rotors have to spin 6 times faster on Mars than they would have to spin on Earth. I think we're singing the national anthem here is what's going on. Oh no, America the Beautiful, I think is what it is. We're gonna keep, I don't mean any disrespect, but we're gonna keep talking because we just started here. So where is it launching from? So we're launching from Cape Canaveral, Slick 41. I'm pulling up my, here we go. We'll pull this up here, which is our flight simulation here, and we can take a look at the 3D flight path here, and you can actually see exactly what's happening. So we're launching from Slick 41, which is down here at Cape Canaveral, Florida. It's actually in between the two SpaceX launch pads. So you've got pad 39A. We can zoom in a little bit further. Will give us clear imaging here, maybe. There we go. So up here, starting up at the top, 39B launched Apollo Space Shuttle, 39A Apollo Space Shuttle, SpaceX launches Falcon Heavy from here, launches Crew Dragon from here. Then pad 41. This actually looks like it's not pointed to the right pad. But this is pad 41 right here. I'm not sure why this goes to here, but this is pad 41. This is actually launch pad 40. This is SpaceX's pad. So we're actually launching from here. I'm not sure why this simulation shows it here, because we're launching from 41, which is up here. This is ULA's launch pad up here. This is actually SpaceX's launch pad a little bit lower. There it goes. Well, let me zoom in even further. Yeah, this is ULA. ULA is the top one. But the important thing, we're going to zoom out and take a look at the flight path here. And you can see, I always struggle with trying to manipulate the controls here. Oh, yeah. Oh, now we're sideways. All right, everybody just turn your head. You see, I never know how to do this. Well, now I just... Oh, there we go. We're kind of back to normal. Okay, well, you get the idea. We're launching to the east. Roughly equatorial orbit. It's actually going to be a little bit inclined. I don't know. Yeah. Somebody needs to give me a lesson on how to operate the Flight Club controls. Anyways, that's the rough trajectory right there that it will be heading on after launch. So it'll be launching, and then about an hour later, there's two upper stage burns, and then an hour later after launch is when separation is for the Mars 2020 rover, and that's when it starts its 7-month journey out to Mars, be landing in February. All right, let's take a look here. So I do see everybody's comments. We're gonna go back through and say hello to everybody, but I see some people, we got a couple people hanging out on Periscope. That was Killshot on Periscope that asked where it was launching from. And Perry Goad checking us out on the Twitch channel. Good morning, and Perry Goad. My buddy Chad Colby. Chad and I went to the NASA Social down pre-pandemic. Which one was that? CRS 17? Is that what we went to? It was like a little over a year ago. Seems like a decade ago. Good morning, Chad. Let's see. Let's go back to some of the YouTube comments and see what's happening here before we get into some of the other stuff that we're going to take a look at. Awesome shirt. Everybody likes my shirt. Well, thank you very much. It's kind of an old shirt, actually. Two-door question for you. How does SpaceX actually get the awesome shots from Falcon 9? Well, I'm not sure which shots you're referring to, but there are tracking cameras. There will be tracking cameras here as well. There's ground-based tracking cameras that will watch the actual launch itself. Those are, I mean, they're really nice to see, but for the most part, they are for engineering purposes so that they can see what's happening with a rocket. Especially if something were to go wrong, they need that for analysis after the fact. But they use them too when things go right. So there's tracking cameras on the ground, and then the cameras that are on board, like the second stage where you see the engine bell, that's just a live video feed that's transmitted back to ground stations. We don't usually see that. The Atlas has cameras on board, but they don't usually show us them live. So we'll see. I mean, maybe they'll show it to us live today because of this particular mission, but they don't usually show us the live camera feeds from the Atlas V. Oh, let's see. Can I do this split? No. This split? No, that doesn't work. Oh, all my splits are... We'll just go back to this one. Tracking cameras on satellites too? No, they don't do tracking cameras on satellites. They're just I mean, they're not going to show us tracking cameras on satellites. I don't think you're going to see, I don't think they have tracking cameras on satellites to begin with, because it'll be really difficult to try to navigate the moving satellites. I mean, you could potentially do it maybe from a geostationary satellite, but yeah, most of the cameras that we see for like engineering purposes are ground-based cameras or onboard cameras. We don't really, there's not really a need for satellite-based tracking cameras. Let's see. Keep talking. That's why we're here. The other. Oh, am I showing the? Was I showing the Anasis 2 simulation? Hold on. Everybody says I was showing the wrong simulation. I thought I updated this. Oh, it is the Anasis 2 one. Well, thanks for the tip there. Hold on. Why did that not update? That's why it's showing. Well, so I showed you the wrong flight path. I was wondering what was going on there. Let's go look at it again. I swear I updated that this morning. 3D visualization. Where's my Earth? Now I can't find Earth. Well, there it is. Okay. Yeah, there we go. That's weird. We're Anasis and Mars 2020, pretty much the exact same orbit, almost. So this is the Mars 2021. That was so weird. Let me see if it's showing the right pad here now. Oh, yeah, there we go. Well, good catch. Who was that told me I was showing the wrong one? Chris Watson. Thanks, Chris. No wonder why I was showing the wrong pad. It was the Anasis launch. This is the Mars 2020 launch. But the orbit is almost the same. This is the Mars 2020. That's the Mars 2021 right there. It's very similar. Slightly inclined. All right, well, now that we got that out of the way, I'm going to keep that up so we can go back to that later. Let's get back to our live feeds here from the pad. So we're about 17 minutes away from launch. Still everything on track and good to go. What? Let's see. Yeah, you're not going to be able to view it in the UK because this is... it's a slightly inclined orbit, but it's close to equatorial, so it's not going anywhere near the UK. It's actually going slightly southeast towards the equator. Just checking to make sure we didn't have any updates on flight status. We can turn up we'll turn up a little bit of their talking as well, because we're gonna go, we'll switch to their feed in a minute so we can listen in. Give a link to Flight Club. If you type !path, it should give you the link to Flight Club that the new one that I just showed. Pretty sure I updated it. You may have to check it, but !path should give you the flight path there. What time is the launch? About 16 minutes from now is where we're at right now. Are you covering undocking and splashdown of Crew Dragon? Yes, I will definitely be covering that. We'll have an event up on the YouTube channel here shortly, probably after this, once we get an idea. We're kind of looking at, and we can look at actually weather here for today. Let's see if this one. Why am I'm hearing myself back in my microphone? Why am I hearing myself? We're gonna look at sensors. I got all kinds of technology issues this morning. Oh, my stream is playing in the background. That's why. All right, whew. We're gonna make it. Let's deorbitate this this stream here. All right, so let's take a look at here. I want to take a look at the actual sensors that are on board the Mars 2020 rover this morning. So I mentioned we'll start at the Mastcam Z there, that the zoomable panoramic cameras. Those are the upgraded cameras that I'm super excited for. There are other cameras on board, but that's the one that I'm most excited for, is that panoramic camera there, the Mastcam. They also have the SuperCam, which is a micro imager. They've got the weather station, the META weather station that's doing weather, or monitoring the weather on Mars. You've got Sherlock, which is ultraviolet spectrometer. That's mostly that, along with the Pixel, the X-ray spectrometer, is what they're using for detecting microbial life potentially on Mars. So that's what those sensors are. You've got MOXIE, which is producing the oxygen from the Martian carbon dioxide. So it's taking the carbon dioxide in the atmosphere, because Mars's atmosphere is mostly carbon dioxide. So it's going to take the carbon dioxide out of the atmosphere and try to produce meaningful or efficiently produce oxygen from it. RIMFAX is the subsurface radar. That's actually going to be sending radar into the ground underneath the rover to try to get an idea of what the ground composition is underneath. And then what's not shown here is the Ingenuity helicopter, which is also on board. This is, again, size-wise, this is like the size of a small SUV. It's huge. It's a huge, huge rover. The helicopter is not huge. It's only, this big. Though the rotors are big. I guess that's the box that it's in. The rotors are huge. Rotors are huge for the helicopter. What if the cameras become dirty? Well, they can clean those cameras. So they have I forget the exact method that they do it, but they do have the ability to clean it. And I think they can use, I think it has onboard cleaning on the actual camera itself. But I know they've cleaned them before. Does the helicopter have a camera? No, the helicopter is very, very lightweight. There's really not much on the helicopter. Oh wait, no, that's not true. The helicopter does have a camera. Sorry, the helicopter does have a camera. But it is very, very lightweight. Has just some batteries, and there is a camera on board the helicopter. What is the landing sequence? Well, landing's gonna be in February. I didn't really pull up the landing sequence here. We'll have that up in February. Why isn't SpaceX doing this for NASA? I mean, they choose launch providers based on a number of reasons. I mean, ULA has a history of being very, very precise with their launches. Not that SpaceX isn't, but precision is ULA's thing. They also, they've been developing this Mars 2020 rover for a long time before Falcon Heavy was really ready. And so they had to, this would have had to have launched on Falcon Heavy in order to get to Mars, but Falcon Heavy wasn't really ready and a provable platform at the time they developed this, and they have to choose the platform that they're going to launch on pretty early in the development process, because all the integrations for separation and powering it while it's on the launch pad, and keeping your mission clock in tune, which we got a lot of publicity on the Boeing mission, all that stuff has to be integrated early on in the process, and so they have to choose a launch provider pretty early on. Just like the James Webb Space Telescope, which is launching on an Ariane rocket, that was decided a long time ago. So it's been many years in the making. Remember, Falcon Heavy has only been flying for 2 years, and it's a very capable platform, but it would have had to have been ready like 6 or 7 years ago in order for them to fly this mission on it. So we'll see. You could potentially see Falcon Heavy flying missions like this further into the future. James Webb Space Telescope is 20 years late. Yeah, I know it is. It is taking a very long time to get there, but it's a very, very expensive telescope. We want to make sure it's just right. There's also a microphone on board. I forgot about that. There's a microphone on board the rover today as well to listen to Mars. Not the first microphone we sent there. InSight had a microphone, has a microphone on board as well, but this also has that microphone so that we can get the sounds of Mars. Not really much to hear except for wind sounds. Hopefully, wouldn't that be interesting if all of a sudden somebody started talking to you or you started hearing weird noises or sounds. What's the purpose of the helicopter? So the idea is the helicopter is just it's a demonstration to prove that flight is possible on Mars. So Mars has a very, very thin atmosphere, only about 1% of what we have here on Earth. And so trying to fly a helicopter in general, a lot of people thought that it's not going to be possible. There's only 1% of the atmosphere. How are you going to generate enough lift from helicopter rotor blades to fly a helicopter? You have to have the rotor blades spin really fast. They spin 6 times faster than helicopter rotor blades would spin here on Earth. 2, the rotor blades have to be huge in order to generate any sort of meaningful lift. So now you got huge rotor blades and spinning 6 times fast. Already you've upped the complications there. And then 3, it has to be lightweight, because if it's too heavy, it's not going to get off the ground. So you need lightweight, huge rotor blades, fast spinning, and kind of those three things make it really complicated to develop a platform that could fly on Mars. I had a bunch of people, I put a TikTok out that talked about the Mars helicopter. Yeah, we got a TikTok. You check it out. That seems to be the platform that I've been posting most frequently on. For video content, at least, just because they're fun and easy to make. It's educational. You don't expect me to dance on there. I'm not dancing on a TikTok. Anyways, I had a TikTok out about the Mars helicopter, and a lot of people ask, well, why don't they just put a drone up there, a quadcopter, 4 rotor blades, things like that. The problem is, you would need those rotors to have to be so huge, you can't put 4 of them side by side like that. So the only way it worked was to put 2 on top of each other. Why don't we pull it up instead of me using hand diagrams? Pulling up the helicopter here now so you can see what it looks like. Okay, here's the helicopter. I was actually looking, I want to pull up the video of it so that we can actually show the video here. There it is. This is better. Let's put the video up instead. But here's the Mars Ingenuity helicopter, their little video presentation. So there it is right there. It's going to be on the underbelly of the the rover. So the rover is going to land. It has it underneath. It's underneath and on its side. So after the rover lands, it's going to kind of swing out and then drop it down. So it's kind of like underneath and on its side. Swing out, drop down. And then it will drive away to get out of the way. Once it's out of the way, then it'll start its demonstration mission. It's only going to fly a couple of times. It's not like it's going to be up there flying forever. I forget what the exact flight time is, but it's pretty short flight time. So you got solar panels up here and a little radio antenna at the top. Then you've got your 2 rotor blades. The first one actually kind of focuses the air towards that bottom rotor blade, and then the bottom rotor blade is actually generating the lift there, but has to spin super, super fast. The Perseverance rover will actually be watching it with its cameras, which will be kind of cool. Really want to see pictures of that. Seeing this will be the first aircraft on another planet. It's kind of crazy. Then you've got the cameras on the bottom, which I forgot about. I'm hearing the... There you go. So Oh, you guys
As
aren't
I'm
hearing this,
watching
are you?
Josh do
There we
the
go.
calculation.
Sorry, I was hearing the launch director. I forgot to unmute that, but the launch director has given the go to proceed with the count here. So we're in a planned hold right now, which is typical for ULA launches. So the countdown is not the same for all the rockets. This is different.
Roger.
All
Fantastic.
steps are complete prior to terminal count. LC switch is ready.
Awesome. So things are really starting to pick up here. You're going to hear more and
So-
more chatter on those nets there.
So we're switching the spacecraft to internal power right now. So that would be the rover is switched to internal power, and we're getting ready for launch. We're only about 5 minutes away here from launch. They've switched it to internal power instead of ground power. The rocket itself is still on ground power. That'll switch to internal power later in the process. I think it's about 2 minutes, T-minus 2 minutes when they switch to internal power on the actual rocket itself. But fueling is pretty much complete at this point with 5 minutes left to go. How long will it take it to get to Mars with the rocket? Well, the rocket won't go to Mars, but the rover will. That will take 7 months to get there. February is the planned landing for this.
And excited.
Yes.
There are a lot of things happening as we get ready to count down to lift off this morning. We have about 15 seconds left in this hold before we pick up the count.
Yeah, we're going to listen into that.
Yeah, from where is a helicopter controlled, and do they expect much lag? Yes, there is a lot of lag, and it is
2, 1, mark.
Awesome. So this is now the terminal countdown. This is that time when things become more and more automated over the next couple minutes,
we
few
go.
minutes. And the energy's building, but the focus is increasing exponentially.
Yeah, as Tori said during his interview, you know, the teams are very distant.
Tori, during his interview, that's not me, that's Tori Bruno, the CEO of ULA. So just to answer the question on the helicopter, it's autonomous. There's somebody's not sitting there flying it with their controller here. The helicopter is autonomous. They send commands to it. They'll send a flight scenario, a flight program to it, and then it will perform all those operations and then send back the results, because the latency to Mars is anywhere from 3 to 20 minutes, depending on where it is in its orbit. So it can take up to 20 minutes to hear back on whether or not it worked. So you can't really go like turn right, then wait 20 minutes to see if it worked. I mean, you kind of need that flight sequence to be a little more responsive than that. So yeah, it's autonomous, but they can send pre-programmed flight commands to it and then tell it to execute those. The same with the rover itself. They don't sit there and they don't drive it like they're driving a joystick. They send the commands to it and say, I want you to do all these things, go, and then it will do that. You can't really control it in real time like that. Watching rockets that aren't recoverable seems dated. I know this used to be commonplace. This is not a recoverable rocket. The first stage will break up and smash into the ocean. The solid rocket boosters, same thing. They don't get recovered. None of this rocket gets recovered. Payload fairings, booster, solid rocket, they're all going to be expended. Now, ULA is working on the Vulcan rocket,
1 minute 59.
which is going to be
1 minute 55.
Launch sequencer start.
Vulcan rocket is going to be reusable.
1 minute 50.
Securing Centaur Leech 2.
Securing Centaur LO2.
So there we heard the fueling is
1
wrapping
minute
up there.
40.
Yep, fueling is wrapping
Launch
up.
enabled.
Team's gone. Launch enable's
137.
done. Launch
looks-
conductor sequence. is
Looks like we may get an on-time
We're getting ready to
launch here. We did have a launch window this morning. It's not an instantaneous launch window, but so far the count has proceeded
T-minus 25
very
seconds. We'll hear the team
nominally.
give their final goes that everything is ready and
1
the
minute
launch
20.
vehicle is ready to lift off and
OCU
perform
arm.
this mission.
What is internal power?
15.
That's just when they stop supplying power to the spacecraft
10.
and the rocket from the ground, and it relies on its internal batteries for power.
1 minute.
Rock, report range status.
Range green.
That's good to hear, Joshua, right
That means
there.
public safety there is accounted for, the FTS system. There you see on your screen a beautiful shot. The skies look great. There is little wind happening. You'd be able to see more of the venting. If there were wind, the trail of that venting. So we're ready to go.
And actually, that's an
40
important
seconds.
point. The reason we don't see that
Stable at
venting is
step
the
3.
vent valves have been locked up to put flight pressure into the tanks. And as we just heard, they're stable
Here
at
we
step
go.
3, which means the
Let's
tanks
go
are
to
ready
Mars.
go. And here at about 5 seconds.
30
we will
seconds
hear
now.
the team
ECS reduced for launch.
give their
Roger.
final go.
25 seconds.
Status check. Go Atlas.
Go Centaur.
Go Mars 2020.
There we go. We are ready to go lift off this morning, Joshua.
Everything's good to go. Let's do it. I kind of expected at least a slight delay, but I guess not. 10 seconds.
8, 7, 6, 5,
5,
4. Engine ignition. 2, 1, 0. Release and liftoff. As the countdown to Mars continues.
We're going to
Perseverance
Mars.
Of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU has gone to closed loop control.
That Atlas V just leaps off the pad. It has such a huge thrust to weight ratio.
Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1 Atlas V is now supersonic.
I wish it would go a little bit louder.
And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure.
So here's Max Q here now, just to give you an idea. Here's the events list real quick. Coming up on SRB Jettison at T plus 1 minute 49 seconds.
And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly.
There you go. Jettison's coming up in about 10 seconds. ULA is also known, I talked about ULA's precision. They're known for their precision and precise launch times and sequencing. So when they say, right there's jettison. When they say it's happening at 1 minute and 49 seconds,
good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance.
Some of the launch, just to clarify
Vehicle
that,
body rates are responding nominally at this time.
some of the launch vehicles will adjust their flight path slightly, or you may have jettison or separation a little bit differently based on the performance of the rocket. ULA's just always nails that flight time.
Minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good.
Next
At
event,
this time, the vehicle is
payload fairing
50 miles in
separation.
altitude, 85 miles downrange, traveling at 6,000 miles per hour.
Payload fairing is, what did I say, 327? T
And
plus.
the Centaur reaction control system is now pressurizing to flight levels.
These are your ground-based tracking cameras that we talked about earlier. Getting really small now. I can't imagine trying to.
3 minutes into flight, the RD-180
Oh, there we
is now
go.
throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good.
Look at this. They are going to show us some onboard footage. I like that. They don't always show this. There's payload fairing SEP. Oh, look at that.
And
Wow.
we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison.
That's pretty awesome. That was a good view.
And the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good.
4.6 G. is the acceleration for that
And Centaur has begun
RD-180
the
engine that
two-phase
they're going
showdown
for.
sequence to thermally condition the RL-10 for operation.
Next big event coming up here
Standing by for BECO shortly.
is BECO. Oh, my separation apparently is... Oh, I have a typo in separation. BECO's coming up at 4:22.
BECO's the call for booster engine.
And we have BECO booster engine cutoff, standing by for stage separation.
There we go. Look at that view.
And we
That's
have good
gorgeous.
indication of Atlas Centaur separation.
Wow. I don't know if we've ever seen, if they've showed that live before. Have they?
So there you're seeing live footage.
And
That's
we
gorgeous.
Have Mach 1. RL-10 operating parameters look good. Chamber pressures are stable.
That
This
is
will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
So, Mick, that's pretty exceptional footage there. That's live video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here as we proceed towards orbit and then towards Mars destination.
Yeah, absolutely. It was great
I know.
watching an on-time liftoff of the Atlas V with that little over 2 million pounds of thrust. Cleared the tower in roughly 5 seconds. Josh, you and I worked the InSight mission, and if you recall, that mission on the West Coast took about 17 seconds to get past tower. So with those 4 solids today, this thing really got out of here and on its way. And it's, as we hear from Jesse, everything's looking nominal, and all vehicle parameters are within the design limits, and we're getting ready to come up on a main engine start for that first burn that Jesse was talking about.
Yeah, so recapping this countdown to Mars, the stations begin to be filled up this morning just after midnight. Preparations, fuelings, powering up, all the way through that liftoff that happened. I think, Mick, it wasn't precisely on time. I think you said it was like 10 milliseconds early. So it's pretty much dead on.
Yeah, dead on. This team does a great job. As I said, they're very focused, very disciplined. As Tori
So I'm gonna turn them down just a little bit here, but our separation, we're gonna go all the way through separation. Separation is not until about an hour after launch, so we still got like 54 minutes to go before the Mars rover separates. But this is a fantastic view. I don't remember them ever showing this live before. This is a fantastic view. I don't know if I've ever seen it after the fact either before. But I love this view. That's the single Centaur upper stage. You can even see a little bit of venting happening from the vent port on the right. Oh, and we lost it. Of course, just as I talk about how awesome it is.
TDRS.
Overall telemetry quality is very good.
The space tracking system. So there you go. This is not an actual video, but this is an animation that's driven by real data. So although we're not actually seeing the engine on screen right now, we can see that the engine is lit, and that is driven by the data that says that the engine is truly lit, and we're in this burn.
Yeah, the launch vehicle continues to send telemetry to the launch team via the TDRS network, as you mentioned, and that allows them to continue to watch what's going on and make sure all their sequence of events meet their timeline. We continue on a nominal flight this morning. This first burn, as we heard earlier, will be about 6 minutes. This will get us into that park orbit around Earth, allow us to get on our way, and then get into that approximately 30-minute coast period that we're going to have.
8 minutes into flight, beginning to see the Centaur PU system balance out mass errors, seeing very stable body rates in the Centaur.
So we've mentioned 5 teams at play, and although
so we're right now we're burning that. This is the first of 2 burns for the upper stage there. This we're waiting on MECO 1, which is going to come at 11 minutes and 27 seconds. So we've still got about 2.5 minutes here of this first burn. Then the second burn is not going to happen until about 44 minutes after launch. So it'll be in this long coast phase for a while, and then that second burn, the main engine start 2, that's the MES2 that you see on the event screen. That's what's going to actually send it to Mars. That'll put it in the trajectory towards Mars. And so a lot of people have asked, too, that why are we launching? Why are so many things launching to Mars? So we just had, there was another Mars mission that launched a couple weeks back. We've got this Mars mission here. Obviously, this is kind of the highest profile one, and there's a finite window there. I mean, they can extend it a little bit, but the right now the orbits of Earth and Mars are on the same side of the sun, and it makes it easy to get to Mars. So it's really about just being lined up to get to it. I mean, what you're taking kind of this big arcing curve to get to Mars. So you're not making a straight line towards Mars. You're taking a big arcing curve. Let's see if we can actually even pull this up. Mars row. But you're not taking a straight line to it. You've got to intercept the Mars orbit. And here we go. This is not the Perseverance. Not the Perseverance rover. Oh, this is the Perseverance rover. Just to give you a quick idea on what the orbit here kind of looks like. So we'll switch back over to launch here in just a second here, but here's the idea. It's basically you're launching from here and you're going to intercept Mars orbit over here, and that's and this is the position of Earth when it arrives at Mars. So we actually kind of pass by Mars during that transit time, and it will head out here and intercept. And so this is just the ideal time to do that efficiently with the least amount of fuel and with rocket technology that we have. If you're in other parts of the orbit, you either need to burn more fuel or you need a more powerful rocket. So this is the ideal time to do that. Switch back to here now. We can see what's going on. Does Mars have aliens? Well, not that we know of, but that's what we want to find out. And that's one of the things that the Mars Perseverance rover is going to do, is look for life. Look for microbial life, evidence of life, active life. That would be crazy to find, but that's one of the things that the rover is doing, is looking for life on Mars, signs of current life, signs of past life. So that's one of the things that it's looking for. Next 2 weeks, oh yeah, and that's a good point from Rattle AU. The next 2 weeks is the best time left for another 2 years for anyone wanting to launch to the Mars due to the planets lining up. So yeah, that window, I said it's a finite window, that kind of expires in about 2 weeks from now, and then we don't get that opportunity again for 2 more years. So this happens every 2 years, we get this launch window to Mars. And so it's really important to try to be, especially for a mission like this, to be on time and not have delays, because if there was some sort of delay, I mean, we could deal with like a day delay, even a week delay, but if this was delayed like 6 months, you missed the window. You're not going to launch until 2022 at that point. So it only comes around once every 2 years.
Thank you very much. Great launch and great job, guys. Back outside now. To recap, an Atlas V rocket carrying Mars Perseverance rover launched on time from the Cape Canaveral Air Force Station at 7:50 a.m. Eastern Daylight Time.
Incredible. After the
Is SpaceX the only ones that land boosters? Is it copyrighted to them? It's not copyrighted to them. They are the only ones that recover orbital class boosters at this time. You have Blue Origin that can recover their suborbital booster on the New Shepard rocket. But SpaceX is the only one that recovers their orbital class booster. Rocket Lab is working on recovery right now. ULA, the Vulcan rocket that they're building, which is going to be launching, I think it's next year. I think 2021, like early 2021, I think is when the Vulcan is going to make its debut. So the Vulcan rocket will be, that will be recoverable as well. So everybody's moving towards recovery. I know ESA is looking at recoverability. I know that Roscosmos in Russia is looking at recoverability. So everybody, this is the way that it's moving. They're moving towards recovering all the first stage boosters. So it's not copyrighted to them. I mean, I'm sure SpaceX has proprietary technology that they use to perform that operation, but the idea itself It's not something that only SpaceX can do. Anybody can do it. They just got to figure it out and develop their own process to do it. China, yeah, there you go. MVM says China will soon be recovering their orbital boosters. Yeah, so there's a lot of people working on that.
Emotional experience. It's almost unbelievable to see it taking off. It's very surreal. That's for sure.
Nice. What excites you the most about the?
Anybody wondering about the trajectory angle? So the trajectory angle, we are at cutoff here now, right? Did we miss cutoff? Yeah. So we've passed cutoff. That was actually a couple minutes ago. So right now it's actually orienting itself for the next burn, and it doesn't really matter. Like, the rocket doesn't have to point parallel to the horizon. It can, Kerbal Space Program is the best way to visualize this, but you can point your rocket and orient it for your next burn, and then as you travel, you might be pointed directly at the Earth here, and then as you travel around and get to the other side where your burn is, now you're horizontal to the, I don't know if that was the best example here. So you're pointed directly at the Earth like this, and then you go around your orbit, and now you're pointed here. So it's not going to stay horizontal the whole way unless you actively control it and make it stay horizontal. So yeah, they can orient it for its next burn now and get it prepared for that. So the orientation doesn't particularly bother me. Is Kerbal Space Program expensive? No, that's the best part about Kerbal Space Program. It's very inexpensive. Very inexpensive, and it's a lot of fun. If you've not played Kerbal Space Program, use your rocket model. Oh yeah, where is my rocket model? Oh, I can't. It's behind the green screen. I gotta get these things out. I actually broke one of them after the live stream. I had to print another one. It fell off. I put in a new desk here, so I have a new desk and a new setup. And after the last live stream, I got rid of the old desk and put the new desk in, which is much bigger. And when I was moving the old desk out, the model fell over and broke. I had to print another one. Just the second stage broke, but I already made a new one. Will the rocket go over Southeast Asia? It should. Yeah, it might pass a little too far south of Asia, but it'll be pretty close to that area. If you type ! path, you can see the exact path. People don't... Oh, that's a good point there, Zazu. People don't get how risky it is to put 11 pounds of plutonium on the top of a massive bomb that could explode in the atmosphere. It is a good point. The rover is a nuclear-powered rover. So there is a nuclear battery on board this rocket, which is risky. It is very risky to have a nuclear-powered battery flying on a rocket. Now, it's not crazy huge, like world-ending huge, but it would be, not great to have it explode in the atmosphere. But that is a good point, because there is a self-contained, like, nuclear reactor on board that rover, which is powering it.
With the earthquake, but you could feel the energy building in the room in the run-up to launch. And now I'm with Bobby Braun, the Director for Planetary Science at JPL. Bobby, now that we've started our journey to Mars, can you tell me how you are feeling?
Wow, it's a great day. We're all so excited, and to get started in this way and to be on our way after all this work that the team has gone through. It's really just fantastic.
That's great. Now that Perseverance is off the launch pad, what are its next steps?
Yeah, well, we're almost on the path to Mars, if you will. The launch vehicle has done great so far. Our partners at ULA are just fantastic, and we're very happy to be working with them and for them to give us this boost so far. But we still have to have another burn of our upper stage. We have to pass through the night side, or the shadow of the Earth, come out on the other side and find the sun and power up, and then establish contact with the spacecraft. And once we do, we'll truly be on our way to Mars. We'll have a spacecraft that's power safe, that we can communicate with, and our journey will really begin.
Yeah, so somebody else, sorry, I want to listen to this for a minute. MVM is a landing similar to Curiosity's landing. Yes, this is very I'm sorry, I didn't realize we were not on full screen there. I wanted to be on this screen. The landing is very similar to Curiosity. So landing sequence, they'll do entry interface. I don't have the exact timing here pulled up here, but they'll have entry interface. They'll come in like a capsule system. You can kind of see the capsule on top there. So it's a capsule system, has a heat shield on it. They'll enter the Earth's atmosphere. Then they will jettison the heat shield. The rocket will be released from the cover of the capsule, and then there's a parachute system that'll slow it down a little bit first. Then it'll jettison the heat shield. Then it will leave the capsule and leave the parachute behind and use a rocket system on board. It's not actually on board the rover. There's the sky crane that's attached to the rover. The sky crane has rockets on it that will fire. We can actually pull up. Why don't we pull this up here while we're waiting for that? So there's a sky crane that will slow it down, and then it actually lowers it down to the surface on a set of cables. Let's see. Do I have a Perseverance landing? Well, we can always look at the Curiosity landing because it's pretty much exactly the same, but I thought I had a Perseverance landing. Well, let's look at the Curiosity landing. It's pretty much the exact same thing as Curiosity. Now I can't find my animation. The animations. Perseverance landing. Where is it?
What were some of the biggest challenges in developing this technology, designing it, developing, building it?
Well, the team that produced the hardware that we just saw being launched on its way to Mars, they certainly had moxie because they had to overcome a lot of challenges along the way. When you start to develop...
Why can I not find this animation? Somebody see if they can find the video for me. I can't find the video of the landing at all. For Curiosity or for...
You've got all the power.
Or for Perseverance.
You can control the thermal environment, and you can have teams of people come in and tinker with it.
Why can I not find this?
So, and you can probably see where I'm going with this.
Somebody send it to me in Discord if you.
Where it's time to fly that hardware to.
If you're in our Discord channel.
Space environment or on the planet.
Because I cannot find it.
Then the rubber really hits the road.
They've gone through a whole bunch of different landing scenarios. So we had the bouncy house thing. We've had direct powered landings. Let's see. Why can I not find? There we go. Sebi just sent me. Is this what I'm looking for? Is this the landing here? Yeah, there we go. There it is. Okay, thank you, Sebi. Sebi sent it to us sent it to me in Discord. Okay, give you an idea here. Let me get out of the way. To give you an idea on what the landing looks like. So here's entry interface. Remember, Mars has an atmosphere. I've seen a lot of comments where people say like, "Oh, well, there's no atmosphere on Mars, or there's no air on Mars." No, there is atmosphere. There is air. It's just mostly carbon dioxide, and it's very thin. It's not breathable, and it's not enough pressure to support life just directly. You can't walk outside, but there is still an atmosphere. So here's entry interface, slowing with the heat shield. Then you'll get parachutes out. So here's your parachutes, supersonic parachutes that will slow the whole thing down. The heat shield jettisons, slows itself down here with the parachutes. Then it's going to leave the capsule system. It'll jettison. That's the rover inside the capsule there. Jettisons that, then it goes under powered flight with the rockets on the sky crane. So the rover itself is kind of packed and integrated in the middle of that sky crane there. And this is the final descent here. And all this is happening autonomously. They don't control this. Once it starts, they just have to wait for it to finish. They don't even know if it worked yet until it's over. So they can't correct anything during this process. It has to work by itself. So the sky crane brings it down under powered flight. Then as it gets closer to the ground, the Sky Crane will actually lower it on these cables here, just like this. This is kind of the crazy part. They lower it on the cables. And the main reason for this is so that you don't get a ton of dust. So a lot of the dust mitigation is just, you know, they have like some of their cameras pointed downwards so the dust doesn't settle on it. They have some dust covers on there, but you don't want rocket exhaust pushing dust everywhere if you can. You also don't want to have huge craters in the ground. Anyways, separates the cables. The Sky Crane flies away and then like literally just crashes itself into Mars. And then you're there. Then the rover's ready to go. So that's what it is. They call that, somebody said the 12 minutes, isn't it 7 minutes of terror? Somebody said they call that the 12 minutes of terror. I think it's the 7 minutes of terror that they call it, right? Now there's a debate. 12 minutes to get data back to Earth? Oh, there is. So, what is that? That is art, not... says, will rock samples be brought back to Earth from Mars by humans or a robot at some time in the future? That's one of the things. This rover on the underbelly actually has sample storage, and one of the things that they are trying to do is actually store samples that they take in this rover in preparation that someday they might be able to return them. And the reason that they're doing that is they're trying to store as many pristine samples as they can before there's too many human-made Earth objects on the planet. So they're actually going to collect samples and store them to maybe be recovered later by some sort of Earth return mission. So you could see potentially at some point, it would be kind of crazy. I don't think there's any, I mean, maybe there's plans, you know, some plans for it, but there's no active development for sending a rover or some sort of ship that would actually take those samples and bring it back. But it is storing samples on board. It could potentially someday, you could have another rover or sample return mission come up, grab the samples from Perseverance and send it back to Earth. That would be kind of crazy, but... do you... No, I'm... let's see. All right, let's go back to the live view. There's actually a scale model, too, there of... I'm going to keep this video up, because I'm sure somebody will ask at some point. And at this point, we'll pull up the events list here. So we're at T plus 27 minutes. We're waiting for T plus 44 minutes, which is the next main engine startup for the second burn that will actually send it off to Mars. Right now, it's in a Earth parking orbit. So we're not on our way to Mars yet. We're in Earth orbit. Oh, there you go. Gregorius says the sample capsules are dropped. I thought the sample capsules were stored underneath in the belly of the rover. Gregorius says that the sample capsules are dropped. They're working with ESA for sample return. ESA will send the collection rover. I thought that the samples were collected and stored in the underbelly of the rover. Am I wrong on that? Because I thought there were a finite number of sample collection storage. Maybe I'm mixing up experiments, but I thought the samples were stored in the underbelly of the rover. Somebody clarify that. No, they are dropped. All right, everybody says they're dropped. I guess I'm wrong on that. Maybe I'm mixing sample analysis. Yes, they're dropped on the ground. You're wrong, sorry. All right, I guess I'm wrong. Everybody says that they're dropped. I thought they were stored. Maybe I'm thinking, maybe it's sample analysis that they're putting in the underbelly. Left on the surface. Everybody says they're left on the surface. Okay. I was wrong then. The overall consensus is that I'm wrong. And they leave a trail of capsules behind the rover. Got it. All right. Well, thanks for the correction. I guess I misunderstood. I thought they were going to be stored on the rover itself. I got two bits of audio here playing. Oh, there we go. That's because this moved on to a different video.
Same interval of time when life
All
is
right.
developing here on Earth. So by exploring the rocks in Jezero with Perseverance,
Oh, ESA is planning to send 2 probes, one with a rocket for sample return and another a rover that'll collect the samples. So it's like rover poo, says Alex Ziggyful.
Great. Thank you so much, Katie. And with that, let's head back to Kennedy Space Center. Daryl?
Much, Raquel. We are back here at the Kennedy Space Center with our most special guest, Moo, and the Perseverance rover. Here it is, a full-scale mock-up of the actual rover itself. Well, Moo, here it is.
Yes.
And so we've learned a lot about this rover so far. So tell me, kind of describe from top to bottom what we're working here. At the top, you've got the mass cam, which is pretty tall, right?
It is
I mean,
very
it's
tall.
towering over your head. It is on a stage, but what does it do?
All right, so I'm going to play, while they're doing this, a couple people have asked for a replay here. I think we ought to do a replay of the actual launch itself. The next rover shows up with a giant pooper scooper. And N. Perry Go says the empty containers are stored underneath for the trip. Maybe that's what I was thinking. Maybe that's what I was thinking of. I don't know what I was thinking of. Here, actually, let's listen into this here for a minute.
Right, and then goes down onto the planet and starts drilling.
Exactly.
What all is here that's going to help us understand more about the geology?
I wish I could make it louder. It seems too quiet to me.
Yeah, there's of course Pixel and Sherlock, the really amazing instruments that are going to tell us about the biosignatures. But in the middle, there is the coring drill.
Oh, there we go.
The real drill will have
I can make it louder.
coring bit, which is hollow in the middle, and there's going to be a tube inside. This is just a 3D printed version. And as it's collecting samples, it's going to have samples that go directly into the tube.
Oh, you've got a tube there. Yeah, show
here's
that
a
the camera
3D
there.
printed tube here. And it's going to go down the middle of the tube as it's acquiring the sample. Once it's done, it's going to dock with the bit carousel here. It's going to ingest the entire bit with the tube inside and the sample. It's going to rotate down to the belly, and there's going to be a little arm on the inside called the SHA, the sample handling arm, to manipulate it, take pictures, assess the volume, and then seal it.
That's fantastic. And so there's quite a bit of robotics happening between this part, the bit carousel, and getting it underneath. As we know, it's now underneath. But here's a special guest, and we're going to duck down. This is the Mars helicopter.
Yes, Ingenuity.
Moo, this thing is going to be actually tucked up underneath the rover. It was a late addition to this project, but it's probably one of the neatest things on it.
It is pretty amazing. 2,400 RPM that these blades are going to spin in counter directions.
Yeah.
It's a little bit under 4 pounds. It's super light. And yeah, it's going to be the first rotorcraft flight on the surface of Mars. It's spectacular.
And you know what's amazing? It will be taking pictures as well, right?
That's
Look
right.
At the blades.
Wow.
These blades turn, right? And they turn in opposite directions.
They
I understand.
They do.
It will have a camera on it. It will shoot live or shoot video.
Yes.
That we will then get back. It'll shoot video of the rover as it's doing its work, right?
Yeah, it's spectacular. And look at the clearance. I mean, this rover needs to clear this helicopter after it's deployed.
All right. Well, thank you so much for giving us the tour of the mock-up. It's just like the real one, except for it's not going to Mars. Well, thank you so much. And so by now you may have heard that this Perseverance rover was named by a 7th grader. And it was given that name, which is very special to us. And so we asked Hidden Figures actress Octavia Spencer to tell you why the Perseverance name is more than just a name to us here at NASA.
All right, so so I was very confused on this, and I'm glad Atulis brought this up. So here's what I think this is where my confusion was. Here's my confusion on the sample collection here. I'm not saying that I was 100% wrong and that you were 100% right. I'm going to say that we're going to share some of this because they do the witness tubes that they collect the samples on. They will store on board. After samples collected, the samples tube is transferred back to the rover's belly. There it is handed off to a small interior robotic arm, moved to inspection and sealing stations. Once the tube is sealed, nothing can enter it or leave it. The tubes are stored in the rover belly until the team decides on a time and a place to drop the samples off on the surface. So they're not just taken and then just dropped right there. They are actually stored in the underbelly. but you're right. They are dropped. They will. Step 3 is depositing the samples on the surface. They will deposit the samples on the surface, but it's not. It sounds like it's not really a trail of samples that they're depositing. At a time and a place of the team's choosing, the samples are deposited on the surface of Mars at a spot that the team designates as a sample cache depot. So they'll collect a whole bunch of samples, put them in the underbelly, and then deposit them all at one time. Depot locations must be well documented by both local landmarks, precise coordinates from an orbital measurements. The cache of Mars samples will remain at the depot, available for pickup and potential return to Earth. So we're gonna both be right. I knew I read that they were storing it in the underbelly. You guys were getting me all worked up here. I knew they were being stored, but you're right. They are being deposited. It's just not, it's at one time. All right. I just had to vindicate myself that I wasn't completely wrong or crazy. I was like, I swear I read that they were storing them on the underbelly somewhere. Okay, there. Take that. Oh, we're both right. How's that? All right, let's do a replay.
God, I'm so glad I'm here, and I'm so relieved. You know, we have a space mission. We're in touch with the spacecraft, you know, and everything is now.
There we go. All right, so let's go back. Let's go back and watch the replay here. Where is the replay? There's launch. We had some great camera angles. It's not gonna. Maybe my stream's not gonna rewind. Okay, well, in a second here, we may just have to refresh the whole thing here.
Make us nervous in February is to entry, descent, and land. You know, so the Mars.
Let's see, back it up.
Public safety there is accounted
here we
for
go.
The FTS system. There you see on your screen a beautiful shot.
All right, so let's go back here.
There's little wind happening. You'd be able to
go back and we'll
if there were wind,
take a look at a replay here of the launch. This is about 40 seconds prior. This happened about 40 minutes ago.
As we just heard, they're stable at step 3, which means the tanks are
Be
ready to
kind,
go.
rewind.
And here at about 5 seconds, we will hear
seconds.
the team
ECS reduced for launch.
give their final go.
25 seconds.
Status check. Go Atlas.
Go Centaur.
Go Mars 2020.
All right, now that I got the volume up
Here
too,
we go. We are ready to go.
see if we can
lift off
crank the
with
volume for launch. So here's your headphone warning. I'm gonna crank the volume up for this. 10 seconds.
8, 7, 6, 5, 4. Engine ignition. 2, 1, 0. Release and liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU has gone to closed-loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1, Atlas V is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly.
We got to see that onboard footage again too, because that was fantastic. Fantastic.
And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance. Vehicle body rates are responding nominally at this time. And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour.
All right, I'm gonna fast
And the
forward.
Centaur reaction control system is now.
Wanted to fast forward a touch to the onboard
And the
footage.
RD-180 is throttling back up to attain a 4.6 G acceleration.
What time-
Engine response continues to look good.
What time was the payload fairing jettison? I want to see that again. I think we missed it.
And we have good indication.
There it is, right there. I think it's like
Just past 3.
327. I think it's.
we have the rocket look good.
Hold on, I want to see that. Here we go. This is the payload fairing jettison. This was cool to see too at 327. Right there. Look at that. You can see the.
And we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison.
That's that second piece there. That's the forward load reactor deck.
And the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good.
Now I want to fast forward again. I'm going to see the.
As needed, a lot of.
We'll go right here. We don't have to listen to this, but this was the other cool view right here. Oh wait, no, we want separation. Where's separation? I want to actually see the separation event. What time was? Who remembers what time separation was at? Obviously, it's past. Well, I guess we'll just wait right here. Want to see the see that separation coming up. This was another good view right there. You can see inside that interstage there. Look at this. That's pretty awesome looking. That's a cool view. I don't know if they've ever showed that before. You can see it kind of thrusting away. You see the engine gimbaling. That's cool too. That's a great view. All right, so let's go back to live here. See where we're at. 42. We're at 42 minutes. Next event coming up is main engine start 2, which is at 44:59. So about 45 minutes. So we got a little bit of time here. Gregorius sent me something on our Discord. What did you send me here, Gregorius? Oh, there you go. There's sample collection. Am I going to be wrong again? Here's sample collection. Let's take a look at sample collection. Let's get rid of the replay text here. We don't need that. Sample collection animation. So this gives you an idea on the actual robotics that are here. Let me get myself out of the way. This gives you get rid of this replay text. Gives you an idea on the robotics, like the finely coordinated dance that the rover has to perform all on its own, between moving this robotic arm, actually drilling out a core sample, and then getting it. I haven't seen this animation before, so I don't know exactly what it's going to show, but it has to move that sample all over the place. So drill comes back up. Yeah, you're going to see it put it here in this little rotating bit. I don't know what all the exact names are, but This is another robotic arm right there. Yeah, you see it pull it out here. And here's your, so these are the, right here, all the sample collection tubes. Or storage tubes that I was talking about. Sample handling, key steps, measure volume, seal sample tube, image at each step, move tube to storage. There we go. And then, oh, here's that was the storage collection. Storage areas there. So that's where it actually stores them in the underbelly. That's what I was talking about. And then it drives off. And then it'll drop them later. So there we go. There's your sample collection procedure right there. Get rid of that. All right, so. Oh, there we go. So we're up to, there's the Centaur second burn. It's main engine start 2 right there.
And again, I think that it's tough with these.
So we've got MES2, main engine start 2. This is the final burn for the Centaur upper stage here. This is going to last about 7 minutes. Almost 8 minutes, actually. Yeah. 7 minutes and change, just short of 8 minutes, actually. So it's a long burn. We don't see that. Obviously, you don't see that on like a geostationary mission because you're going past geostationary orbit. This is actually going all the way out to Mars orbit. So we need a long second burn here. This is what's actually extending and elongating that orbit to escape Earth gravity and head off towards on a Mars intercept trajectory here.
We actually want to bring in now, we have a special guest. This is Dr. Denton Gibson, excuse me. He is a rocket scientist. His official title is
Maybe SpaceX will catch their fairings. Yeah, I don't think the SpaceX Navy is out in force today. But they will be soon. Got astronauts returning here shortly. They're scheduled to return on Sunday. Undocking Saturday night, return on Sunday. That will be crazy exciting. That's going to be stressful. That's actually the biggest thing that Elon was worried about was the re-entry. Not necessarily the launch itself. He said before the launch, he said his biggest worry was re-entry.
That's awesome. And I know in the past you've supported a variety of vehicles. Tell us a little bit about the vehicles that you have supported and the ones you're focused on today.
Yeah, so some of the vehicles I supported in the past is the Delta II, which was a long time.
And then, so separation of the actual Mars 2020 rover is going to be very, very close to right after that MECO 2, that cutoff. So at about T plus 57 minutes. So we're about 10 minutes away from separation of the Mars rover.
Moment to pause and say Denton's there at Hangar AE. That's the NASA Launch Services Program's hangar. They're very proud of that. We call it the telemetry center of the universe. That's where the data for today is flowing. But I wanted to also ask you, is the process the same for all these vehicles? When we talk about,
are you going to be live when Bob and Doug are returning? Yes, we will definitely cover that live. I will definitely be live on Sunday. I'm undecided on Saturday for undocking. I want to see what the events list is going to look like, but I'll probably be live on Saturday too for undocking. So probably be live Saturday night and Sunday. We'll cover undocking, which will probably be just kind of a short, let's see what's happening. And then the actual splashdown, definitely be live for. That will be Sunday afternoon. Did they put a microphone system on this mission to capture the audio, or did they not think of it again? No, there is a microphone actually on the rover, so they will be able to capture audio from Mars. When will Crew Dragon take up its next crew? The Crew 1 mission is scheduled for late September. So that'll be the first operational mission, tentatively scheduled. They have to, once the Demo 2 mission comes back, they're going to have to analyze how the mission went, how everything performed, but tentatively it's scheduled for late September for Crew 1. What time is undocking Saturday night? I think it's 7:34 p.m. Eastern time is the actual undock. And so if we're going to cover it live, we'll probably be live a little bit prior to that. So 7:34 p.m. Eastern time Saturday night. Somebody convert that to UTC. What's that? 23:34 UTC, is that right? Did I do the math correctly there? And then splashdown is 2:42 p.m. Eastern time on Sunday, which is 18:34 UTC Sunday. Did I do that math right? Let me check my math for me. Is that an animation we're watching, or is it live? Where's the camera? This is an animation. It's not a camera. It's an animation that is showing the telemetry from the onboard systems there. It's behind me here. You can't really see it now. It's this one that you're talking about here. That's an animation. It's not actually a camera. You got telemetry up here. When they go full screen, you'll be able to read it. I can't read it now, but this is an animation. There's no they didn't send up a second rocket with a camera on it. This is just an animation, which is actually, we get kind of spoiled with all the SpaceX launches that we see so much onboard footage. This is actually kind of the traditional way that most rocket companies do it, by showing an animation, like Arianespace would do it, or Arianespace would show an animation like this. I mean, most companies show an animation. It's only recently that they started showing live footage, and SpaceX has been doing quite a lot of that. Any news on Blue Origin's new Glenn progress? They seem very slow. Blue Origin, I wouldn't necessarily say they seem slow, but Blue Origin is very quiet about their developments. So don't count them out just because we don't hear a lot. They're just very quiet about what they do, and they don't put a lot out in public. But it's still pushing forward. I think you'll be surprised at how fast it pushes forward. Like, once they do announce it, you'll be like, oh wow, I guess I didn't realize it was this close. Live video from a second rocket. No. When Perseverance rover lands on Mars, we'll be listening to that microphone and hear wind. Yeah, I mean, for the most part, that's what you're going to be picking up from a microphone, is just wind sounds, atmospheric sounds from the planet. And as Sebi said, would you rather hear voices? I think everybody would freak out if all of a sudden you were just listening to the wind on Mars and somebody was like, hey, what are you doing over there? Booster splashdown into space. They stay in orbit. All of these. Well, the first stage definitely returns. I think actually I have a stat sheet somewhere here on ULA. I didn't look to see if I don't think they're bringing back the second stage. I'm pretty sure the second stage is going into a disposal orbit. But oh, here we go. So we're coming up on. We should have MECO 2 here.
And there's the call, and there's the animation again, modified based on data.
RL10 shutdown parameters.
Let's talk about communication for a minute, Nick, because it is not an automatic thing to just shoot information at Earth and have that be usable. So how do we go about communicating not only through launch, but on the way to Mars, and then once we're at Mars?
Yeah, so the important thing this morning is
8:40, yeah, so separation, capsule separation here for the actual Mars 2020 mission is coming up here in just about 5 minutes. Coming up very quickly.
Stage separation, you heard a call out for TDRS, the telemetry network that NASA owns, which by the way is also used for
yeah, Centaur will go into solar orbit. Yeah, so it's going to be in basically a disposal orbit. So the Centaur upper stage is not coming back, but the first stage would deorbit, and that would break up and smash into the ocean. Will SpaceX continue to use their Falcon Heavy, or is there no need? No, they're definitely going to use their Falcon Heavy. They've got at least a couple of missions scheduled for Falcon Heavy. One is at the end of this year. There's a Falcon Heavy mission scheduled for the end of this year. But like Falcon Heavy will get used. We talked about this at the beginning. Falcon Heavy's only been flying for 2 years, and providers would want, a lot of providers would want to see demonstrations before they schedule their payloads on board the Falcon Heavy. So a mission like the Mars 2020 rover, this was scheduled to fly with United Launch Alliance like 6 years ago. And Falcon Heavy wasn't a thing then. We didn't even know if it was going to be ready. And you can't really schedule a Mars rover to fly 6 years ago on Falcon Heavy when you only have a finite window to launch the Mars rover. Like this, there's a window of a couple of weeks that they have to launch. Otherwise, they miss the Mars window, and they'd have to wait 2 years to launch to Mars again. So you needed to choose a launch provider 6 years ago, which was your most reliable platform to get you to Mars. And 6 years ago, that was Atlas V. I mean, Atlas V is still a very reliable platform. One of the things that ULA does great is precision. Like, they are super, super, super precise. Yeah, right now they don't recover their first stage boosters, their payload fairings. They don't have any of that kind of, you know, awesome things to watch. But don't forget that the whole point of this is to get a spacecraft into a certain orbit or to a destination, and ULA is awesome at that. Their rockets are very, very precise, and they hit their orbital targets more accurately than I think any rocket company out there, including SpaceX. Not that SpaceX is bad, but when it comes to precision, United Launch Alliance has that nailed down. Gregorius says the first stage will deorbitate. Yes, first stage will definitely deorbitate. Yeah, and I guess Greg Woods actually has a good point. First stage doesn't even reach orbit. Technically, it's suborbital. So it doesn't really would you call that deorbit if it's technically suborbital in the first place? It's just coming back. It's following its ballistic trajectory, and it's coming back to Earth. It doesn't really, never gets into orbit in the first place, so it doesn't really deorbit. SpaceX has a long way to go to get qualified for this type of mission, probably a decade before they do that, or 2 years. I don't know about a decade. Decade seems like a long time. SpaceX is moving very quickly, and NASA is actually moving very quickly to upgrade their fleet. Actually, let's listen into separation. I'll come back to that here in just a second.
Very good performance from the RCS system, and stable indications from the avionics systems as well.
So RCS there, the reaction control system, that's those small, the series of those small engines that you see firing around the spacecraft. Those are used for that in-flight operations that they need. The rolling activities, as Mick's saying, is basically providing stability to the flight of Mars 2020 as we go forward. Tell us about actually...
And we have successful separation of Mars 2020 with the Perseverance rover.
Off to Mars.
Awesome. We got some nice applause there. That is a big moment. We are hoping to get some live video back from that because of the time delays with communicating with things in space. We don't have it at this instant. We're hoping we'll get to see that here in a few minutes, and we'll bring that to you if we do. But tell us about the separation maneuver, because the apparatus, the actual... It's a really simple design.
It's a separation clamp. We'll talk about that in a minute, but as you see on your screen right now, you see the Mission Director Center where Omar Baez and the team are. And Josh, you and I joked about this a little bit earlier, but with the pandemic and everything going on, the teams have done a great job. Normally, spacecraft separation.
2020 with the Perseverance rover, the Centaur will now perform its standard propellant blowdown sequence to inert the vehicle and complete today's flight after completing its CCAM avoidance maneuver. This will conclude today's commentary of the Mars 2020 mission. This is Atlas Flight Commentary signing off.
So that's the end of ULA's job for today.
Jesse Gonzalez did a great job with the ULA commentary this morning. But what I was saying about the Mission Director Center is...
I hope they show us live footage of that separation. They said that they have live footage, but I guess it's not really considered live footage if they're not going to show it to us live. They have footage. It sounds like they have time-delayed footage. They have footage that's going to come back down that we can play later. Sorry, I'm just laughing at that guy in Mission Control. It's like this capsule separated, and he grabbed his backpack, and he was like, "Well, all right, I'm out of here. See ya." I don't know. I found that funny. He was like, "It's like, yeah, well, that's all. That's what they paid me here. They paid me to get to separate, and I'm out of here. Goodbye." He's leaving. I don't know, that one. That made me laugh. He grabbed his backpack and he was out of there. He's not staying 1 minute longer than he's required to. Let's see. I missed it. Can you replay the backpack? Yeah, sure. Hold on. Let's replay the backpack.
We're gonna wait for acquisition of signals. Stay with us, but really fast, Mick, tell us very quickly about this mechanism, because we teased it.
We teased it. Yeah.
How do these things separate?
So the separation system
Hold on.
is called
I'll
Marmon
replay.
clamp band.
I'll replay the backpack guy in a minute. I want to listen to this.
Karl Marx, one of the Marx brothers. Very simple design, but it has some spring systems in it that once the signal is sent and the bolts release the clamp band, the springs basically just give just enough force to push the spacecraft off the front of the vehicle.
Awesome. And again, hopefully we'll see that video here momentarily. But for now, we're going to send it back to you and check in for one final time in a little bit with the folks here at ASOC. But Daryl, back to you.
All right, thank you, and great.
All right, so let's play backpack guy. I'm sorry, whoever backpack guy is. I'm sorry to pick on you, but it was just funny to me. It was let's back it up. It was just very funny to see everybody was like celebrating, and then. So yeah, here's everybody celebrating, and then this is the guy right. Where is it? Where's my mouse? Right here. This guy. He's just like, okay, yep, I did it. I did what I was supposed to do, and we'll see you guys later. I'm off. Thumbs up. Goodbye. I don't know. I mean, it's probably normal, but it just caught me because it was like, it's like they're showing the launch stream where everybody's celebrating. They're like, yeah, look at Mission Control. Everybody's professional. Everybody's excited. They're all doing their jobs, and this guy's like, see ya. Oh, sorry. It's probably not fair of me to pick on him like that, but it was just funny. I liked it. All right, so we're waiting. I guess the one thing... Can I go play Fortnite now? Scientist version of a mic drop. Yeah. I'm off to walk the dog. Probably can't... it probably needs a break. Yeah. Well, that is true. You got to think that they've been on station there for many hours. Like, we've only been going for an hour and a half. He's probably been there for like 6 hours. He's probably tired. He's like, I've been sitting in this chair for 6 hours. I need to take a break.
You've searched for signs of life in some of the most extreme environments on Earth, the Antarctic, the Arctic. So you're used to looking for these biosignatures. What are your thoughts about this rover searching for signs of life?
Yeah, we have a lot of experience looking for signs of life in unusual environments here on Earth. So if you take a look at Mars today, it's very cold and very dry, and we have some places on Earth that are actually a lot like that. So places like Antarctica or deserts. But if you want to look for signs of ancient life that existed billions of years ago perhaps, when Mars looked maybe a lot more like Earth does today, you have to know what those signs of life left behind in the rock record. Because microorganisms are very tiny and very soft, so they don't leave a fossil the same way a dinosaur would leave a bone or a footprint. So instead we use these chemical signatures.
Daryl's dreams is shattered again. We told him there's going to be no dinosaur bones on there. He really wants them.
Something wiggling around, but no.
So why do we need to go to the moon before we go to Mars?
That's such a good question, because we've been to the moon, right? But we haven't been to the moon to stay. We really don't know how to live off of Earth on another planetary body, and we really need to figure out how to use resources, use tools, especially if we want to do geology on Mars. The tools that we use here on Earth are going to look pretty similar, but they might not work quite the same way. And because the round trip to Mars is so much longer than the round trip to the moon, when we go, we want to do it right.
Very good. And how do you like that rover behind you? Huh?
Oh my gosh, I love it.
Yeah, it's great. Hey, I want to ask you some social questions now. These
Absolutely.
are some from our audience who have been watching.
Oh,
so
great.
We appreciate you.
Well, I was hoping that video would come in pretty quickly.
Will Perseverance land to investigate the landing site for a future manned
That we're waiting pretty much on the video of capsule separation. I was really hoping that they would have that up here pretty quickly, because that's going to be pretty much the end of our coverage for today. But I do want to see that. I want to see that capsule separation video. That would be pretty awesome.
Versus landed in the ocean, your vision of Earth might be quite different. So one possible approach is taking a human mission and going back to somewhere where these rovers have been already, or maybe we'll decide to explore somewhere new. I have no idea yet, but I can't wait to find out.
Awesome. It looks like we have another social media question from Twitter, from Huda. Do you think that in a few years we'll be able to send astronauts to Mars in a safe way if we are able to send a rover like Perseverance to Mars in a safe and amazingly planned way?
I hope so. We won't go until it's safe for humans for sure, and we're not going until it's a round trip. But actually part of this mission, of course, is a round trip, and so we will eventually learn how to send a rocket to Mars and then have something lift off of Mars and come back.
Awesome. Well, Zena Cardman, thank you so much for being here. You did a fantastic job. You were a great guest, and glad you enjoyed the launch.
Oh my goodness, it's impossible not to.
No doubt. All right, thank you
both.
Now, as you can imagine,
all right, still no video on that separation here.
And prove out as we prepare for sending humans to Mars, as you just heard. Here now are 6 technology disciplines that are critical to the success of our future explorations.
All right, let's do, as Steve said, do a replay of the launch. I missed it. Well, let's do another replay of the actual launch itself while we're waiting on that. Somebody will have to, let's see, I'll have to, like, open this in a separate window so that I can see if they show that separation. But let's take a look. Let's go back and replay the launch quickly. It's not far enough back. All right, let's do another launch replay. And we'll crank the volume again while we wait for footage, hopefully, of that capsule separation. All right, let's turn it down here. We're about...
The vent valves have been locked up to put flight pressure into the... And here at about...
Status check.
Go Atlas. Go Centaur.
Go Mars 2020.
There we go. We are ready to go lift off this morning, Joshua.
Eight, 7, 6, 5, 4. Engine ignition 2, 1, 0. Release and liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1 Atlas V is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. Passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly.
So they're coming up on SRB burn up and separation. Two things that I think are pretty awesome about the Atlas V that I don't think come across in the live video. One, the thing just leaps off the launch pad. I mean, with those 4 solid rocket boosters, I mean, this thing just takes off in a hurry. So that's underappreciated. But also, when I watch the Atlas V in person, like, those solid rocket boosters are so bright. They look like the brightest firework you've ever seen. Like, that really doesn't come across in the video, I don't think. Like, they're so bright, and it's almost like a metallic-y looking flame to it. It's really cool looking to see in person.
Responding nominally at this time.
I also wanted to say that I've got the live feed up here on another screen so that I can see if they play the footage. They've actually got a timer on the bottom that says time till signal acquisition is about 14 minutes. So I guess we're going to stick around for about 14 minutes until signal acquisition, when they will hopefully play
engine response continues to look good.
Some live footage from the capsule, maybe, or maybe it's separation footage. I don't know if they're going to show us video of separation, or it'll just be a live feed from the capsule itself, or a live feed from the Centaur. I don't know what it is, but they got a countdown on the live feed that's just under 14 minutes until signal acquisition, and I think that's what we're waiting for to get video. So I guess we're waiting about 13 or 14 minutes here.
And just past 3 minutes into flight, the RD-180
there we go. There's that.
To maintain a constant 2.5 G acceleration limit for payload fairing jettison.
That view from the first stage there looks amazing. I love that view. Here's separate. Oh no, that's payload fairing right there. Payload fairing jettison.
Good indication of payload fairing jettison and Centaur forward load reactor deck jettison.
Also really cool to see. Will you be live for the next Starlink? Yes.
Throttling back up to attain a 4.6 G acceleration. Engine response continues to look good.
Yeah, we should cover. I know Starlink was.
Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation. Standing by for BECO shortly.
Do we have an official date for?
BECO is BECO's the call for boost.
Turn this down here a little bit. Do we have an official date for Starlink? I mean, Starlink 9 was supposed to launch in June, and that. Oh, look at that! There's that separation footage. I love that. That's one of my favorite views, right? That might be my favorite view of this launch right there. That separation view. That is awesome. That one right there. So, anyways, what I started saying, Starlink 9 is what we're waiting on. That was supposed to launch in June, and then it was going to launch at the beginning of July, and now it's been delayed a million times. It was going to launch a couple days ago, then they pushed it out till tomorrow, and then they pushed it out again. I saw, like, till early morning on August 1st. So I don't know if we have. I guess it's changed so many times. I guess what I'm wondering is, like, is this date that I have, is this good, or is this an estimate? Yeah, I have August. Right now I have August 1st at 3 in the morning Eastern time, which would be 0700 UTC. Yeah, as Greg Woods says, 721 UTC. That's what I have on my schedule. I'm just wondering if that's going to hold. So that could make for a long Saturday. Saturday at 3 a.m. would be Starlink. Saturday night would be Demo 2 undocking. And then Sunday would be the actual splashdown. So we got a lot going on this weekend. A lot of things happening. And then at some point, maybe by the end of next week, we could get a Starship hop from SN5. Starship 150 meter flight test. That would be pretty awesome. We got a Rocket Lab mission potentially coming up. It would be interesting to see what Rocket Lab has to say about their last failed attempt. But they have another launch scheduled for potentially scheduled for mid-August. See if that stays on the schedule. 10 is also supposed to be... Oh yeah, Starlink... I gotcha. Starlink 10 is also supposed to be in August. We don't really have a set date for that, so... We were launching like 3 Starlink missions a month. And then July came around and we didn't launch any Starlink missions in July. And then keep an eye out. I've actually got a video coming out that's a little less space related. It's a little more like history and earth sciencey. But I've got a new video that's going to come out here in the next couple days. It's actually done and it's uploaded on my YouTube channel. I'm double checking it, making sure that I didn't screw anything up. So it's actually done and uploaded, but if you're in our Discord, you might get early access to it. If you're on if you're a Patreon member, you definitely will get early access to it. But I'm not sure when I'm gonna publish that yet. Just double checking, also fact checking myself. I like to make sure that the things that I said are actually true. That's always nice. But we'll have that new video out. A little different video for me. That's coming out here in a couple days. Can't wait to see Bob and Doug. I know, I'm kind of stressed out about Bob and Doug coming back. That will be so stressful, that re-entry. Can't imagine being part of the SpaceX or NASA teams that are involved in those decisions. Let's see, how much time do we have? All right, so we can go back to live here now. Now we're still waiting. We got about 7 minutes until we get acquisition of signal, and then hopefully we'll see some final video footage, and then we'll call it a day here. But that was an incredibly clean countdown and launch today. Like, no issues whatsoever. It just first try, no weather, no nothing. Actually, speaking of weather, while we're waiting here, big concerns this weekend for weather for the Demo 2 return. We've got this tropical storm here that's expected. This is Tropical Storm Isaias. Is that how we say this? It's expected. This is the... Let's see. The expected return time for the Demo 2 mission. Look at the tropical storm right in the prime recovery area. You ever watched Apollo 13 where he's like, flight, I'm watching a tropical storm warning on the edge of the prime recovery zone. This is not even the edge of the prime recovery zone. Right now it's predicted to be like literally center stage of the prime recovery zone for Demo 2. Now Demo 2 they have a backup recovery zone over here on this coast. So maybe, and right now they've said that they're go. So if this stays offshore like this on the East Coast, they'll probably splash down in their secondary recovery zone over on this side. So it'll be interesting to see. They need winds are probably their tightest margin for recovery for SpaceX. They need to stay below 10 mile per hour winds, and right now the secondary recovery area at 7, 8, 9 mile per hour winds, that would be okay. But it depends on what the track is for this tropical storm, because right now, how do I get to current weather? Current weather, what day are we on? The 30th. 30th, 9 a.m. Here's current weather. So the storm, where is the storm? It's way down here, right? Yeah, so the storm's way down here. It's got to make this trek, it's making this trek this direction. And the question is, does it turn up the coast here and go up the east coast? Does it go, you know, right down the center line of Florida, or does it swing wide and go up the west coast? If it swings up the center of Florida or up the west coast, even just you know, as long as it's not like if it goes way out of the west coast, then you could come splash down on the east coast. If it goes just a little bit like this, it's probably gonna crush both of your recovery zones, which would be a problem. If it swings up to the east coast and makes the turn early, then you could recover in the secondary recovery area. But I guess what I'm saying is I don't know how it's going to be possible for them to splash down in the prime recovery area. I don't know how that's going to be possible. I mean, here's, you know, 8 a.m. Plus, you got to think your waves are going to be pretty huge too. So, let's see. We can look at waves. Yeah. So here, here's waves. These are 12-foot waves off the east coast. I mean, this is 8 a.m. Here's 2 p.m., which is splashdown. I mean, your waves. This is pretty much the prime recovery area right here. It's like dead center. Like you can't play in this anymore dead center on the prime recovery area. But secondary recovery area over here, 1-foot waves. That's not bad. So I'm guessing they'll still come back on Sunday, but it's probably going to be the secondary recovery area because the weather's not looking so hot for the prime recovery zone. I don't know who this guy is. We got 3 minutes though to acquisition of signal. This was the speedy. Did I miss the context of that? Rocket 3.1 Astra Spaceport Complex in Alaska is on August 2nd as well. See, the Florida gods are mocking SpaceX after such a clear sky today. I know, right? You got this tropical storm coming in. Why don't they land off the west coast of Florida? Surely the area would be least prone to weather as opposed to the Atlantic. Well, I think, yeah, so the west coast of Florida is their secondary recovery area. The prime recovery area is just off the east coast because it's closer to Port Canaveral, where they can get their ships in and out faster, easier. They can get the crew back faster, easier. They can get the capsule back faster and easier. So it's just landing off of Port Canaveral makes things easier, but they can land off the west coast if they need to. It just means that the capsule, once they load the capsule on the support ship, they got to make the trip all the way around Florida to get back to Port Canaveral. So if they land here, they just have to go. If they land over here, they got to go all the way around. That's really the big difference. But if this is what we're looking at for waves and wind during splashdown, there's no way they're gonna splash down on the east coast. They'll have to go on the west coast in the secondary area there. What site are you on there? This is called VentuSky. If you type !weather, our friend Nightbot will give you a link right to it. It's going to give you a link to today's weather for today's mission, but you can just change the date to get to here. All right, we're almost there for acquisition of signal. We're just waiting. Did we miss it? We didn't miss it, did we? I don't see the countdown anymore. There's NASA JPL. So I guess we're waiting for acquisition of signal from NASA JPL, maybe? And we'll see maybe the Perseverance rover in the the capsule, really. Don't really see the rover. This is the JPL mission control here. That's where they will be during the Perseverance landing. That's where they will go through the 7 minutes of terror and wait for the actual landing itself. Did we decide? It's 7 minutes, right? There was a debate about 7 or 12 minutes. I think it's 7 minutes.
Acquisition of signal.
Wait, I turned it up late, but they're waiting for acquisition of signal. That was not the actual call for acquisition of signal. So United, at this point, United Launch Alliance's mission is done. They've separated the capsule. It's good to go. Now it's on to NASA JPL to monitor the mission, monitor the capsule, the rover health for the next 7 months, all the way to Mars. And then they'll prepare and monitor entry, descent, and landing. Can they just return a couple of days later? Can who just return a couple of days later? Oh, you're talking about the astronaut? Yeah, they could. You could always delay the...
20.
Oh.
Mem, Reggie signed.
I see fist bumps in the background. There you go. They're receiving data.
Copy that. Radio science.
Flight nav. Go ahead, nav. We're seeing one-way data.
34, so you say US.
Didn't copy, nav.
Yes, sir. We see AOS at 131531.
Ace copies. Thank you.
So that's the official acquisition of signal. They've got it. This guy just took a picture of his screen. He's gonna get in trouble for that. Maybe not.
Flight telecom, I was about to pull up my contingency.
We now have an acquisition of signals. The rumbles now are of claps and cheers, and it's an amazing moment.
Her audio is not synced up with the video there.
Every person who worked on this mission is now realized as Perseverance makes
Why
its
is our
way to Mars now.
Why is our audio and video not synced up?
I want to know your reaction to getting the acquisition of signal.
Well, Raquel, it's very nice to have the spacecraft in a safe, separated, on its way to Mars. Nav looks good.
Why do I have... Hold on. I have like two... Apparently I have two feeds open? Do I have another feed? I'm hearing... This is not the feed that's actually playing... Where is the other... Is it here? No. No. Oh, right there. I have two feeds open. Did not know that.
What are you looking forward to next?
I'm looking forward to, ideally, a very quiet and boring cruise to Mars as we prepare for the never boring and always stressful entry, descent, and landing on the 18th of February.
Great. Thank you so much, Adam, and we hope you tune into our coverage of the landing happening on February 18th, 2021. Joshua and Mick, we here at JPL would like to thank you and the entire launch service program and United Launch Alliance teams for all your amazing work today and all the work you do every day to make a launch like this possible. Now, Joshua, back to you at the Cape.
Raquel, congratulations.
All right, so at this point... It's off. It's on its way to Mars. They've successfully launched it. They have acquisition of signal. They're in good shape. I don't know why. Like I just, for some reason, I was just like waiting for something to not go right today. I don't know why. I just kept having that feeling that I was like, something gonna. I felt like it was gonna be delayed today. I felt like we weren't gonna launch on time, and it was either gonna be pushed later in the window today, or it was going to be pushed to another day. And so, but everything went perfectly today. They launched right at the top of the window. Separation, acquisition of signal, everything was perfect. It's fantastic. So we need to replay a ULA bad guy. I don't want to harp on ULA bad guy too much.
So about a minute ago, we did get acquisition of the spacecraft signal. That signifies that JPL's
is this the bad guy?
Space Network has locked onto the spacecraft. It's on its journey to Mars. Everything appears to be going nominally for them. They'll get to check out the spacecraft now, do those checks that they need to do to learn how to fly that vehicle the way it wants to fly on its way to Mars. Pretty interesting. We separated them at approximately 25,000 miles an hour, and it's going to take a couple of months to get to that February 18th landing date, which they're targeting. So it's an impressive amount of speed that we imparted to them, and that speed is what...
Who is the camera guy, and why can't he sit still? Wait, do you see how much this camera is bobbing around? It's bothering me.
Heavy lifting now is on our partners at the Jet Propulsion Lab. To slow it down when it gets to Mars, up the parachutes, slow them down in the atmosphere, and extend that sky crane and land on Mars. So they've got a heck of a lot of work to do from here on out. Today's count went beautiful up until the last 20 minutes. Started to get exciting with some of the assets on the range having dropouts. And then a surprise call from the spacecraft mission director that we had a small earthquake in California at Pasadena that the folks in the control room felt. But they never lost signal, and they came back to me and said they were ready to proceed. We were able to lock down the time we were after. Launched on time. Perfect launch from what I could see visually here in the control room. The orbital parameters look dead on. Our velocity is dead on. So we're on our way to Mars. There's no way back. So good luck to the Mars 2020 team. It's been a pleasure to be part of this. I've been with this roving Mars community since Sojourner.
Hey, the cameraman, like, forgot to use the bathroom or something before filming this, because he... Why is he moving around so much? Just stand there. Hold the camera.
That becomes that club, that auto club of roving on Mars. And I just want to say I'm very proud of this team. This team has worked diligently to get here. It's hard enough to get to Mars, throw in COVID. Today we're dealing with a small earthquake, the threat of a tropical storm heading in our direction. It's just an immense amount of pressure on the team, and it's so relieving to be able to have gotten that mission off today on the first attempt. And with that, that closes the show for us.
Awesome. A big thanks to Omar.
All right. Well, that was a nice, aside from the camera, man, the camera work. I don't know why it was bouncing around so much. Even if it was a phone camera, I feel like you can hold it steadier than that, right? Oh, well, that was a minor thing, but... All right, let's wrap this thing up here today. We got more space activity happening over the weekend between maybe Starlink Saturday morning, undocking from the space station Saturday night, splashdown Sunday afternoon. We got a whole bunch of things happening in the space world over the next couple of days, so we'll be back for all of those. But it looks like everything's in good shape for the Mars 2020 mission. Now we just have to wait another 7 months to February 18th, 2021. Put it in your calendars now, because it's pretty. They can't delay for weather for the landing. Like it's going in. So February 18th, 2021. Put it in your calendars. I'm sure we will. Well, I'll try to be live. I have no idea what's happening in February 18th, 2021, but if we can, we'll be back for it. And other than that, we're done. That's it. We're finished for the day. I think now we're gonna wrap it up and close everything off and head out. So if you want to chat afterwards, join the Discord. You can type !Discord in the YouTube chat to get an invite link to our Discord channel where we chat it up after the show, between shows, all that kind of stuff. You may get some early access to the new video coming out in a couple of days, probably next week, and you can get a say hello and jump in there and talk with us. And yeah, I think other than that, we're all set. So I'm going to wrap it up here. Tori, do you want to stream SN5 today? I don't have a live stream for SN5. I know SN5 is doing the static fire. I know like Lab Padre has the live stream, which we could talk over the top of that and provide commentary on it. I'm probably not going to live stream the static fire. I will definitely try to live stream the flight attempt. I don't think I'm going to live stream the static fire, just because those static fires, like they have such a huge variation on like whether or not they'll actually happen. I mean, you could go for 5 hours waiting for a static fire and get to the end, and it's like, nope, not today. It's just it's a long time to not have anything at the end of it. So it's so yeah, I don't think I'm gonna do the static fire, but I'll try to do the flight attempt, depending on when that is. But we can chat it up if you want to talk with me. I'm sure I'll be popping in and keeping an eye on the static fire. So if you join the Discord, I'll be around. We can chat some more. So, hey, Adrian, thanks for the super chat. Thanks, Tori, for another great stream. Well, thank you. Appreciate you guys hanging out and joining in with us today. Thanks to everybody on all our platforms: YouTube, Facebook, Periscope, and Twitch. We had a good time today. I'm pleasantly surprised at how uneventful this was. No weather delays, no rocket delays, no delays of anything. Just launch it and head to Mars. Easy peasy, like we've done it before, right? So we'll just have to check in on it. February 18th, 2021. Set your calendars. All right, guys, that's it for me. I'm going to end it right here. Maybe see some of you guys over on our Discord channel afterwards, but that's going to do it for me. My name's Tori. This is Overlook Horizon. Thanks for hanging out with us today. We'll see you hopefully this weekend for some more space flights. All right, thanks, guys. Have a good rest of the day. Goodbye.